Hello everyone. Once again welcome to PM Networking. Hope you all are doing great. Guys, today in this video we are going to understand configuration of DMVPN. Like configuration of DMVPN phase 1, phase 2 and phase 3. We have 3 phases in DMVPN. We are going to discuss all phase 1 by 1. First we will understand phase 1, then we will discuss what is the problem with phase 1, why we come up with phase 2, then we will discuss what is the problem in phase 2, the reason why we come with phase 3, and then we will see the phase 3, right? Configuration of each phase. I will configure actually multiple protocol as well on DMVPN, like static routing, how you can implement a static routing with DMVPN, how you can configure RIP protocol, how you can configure EIGRP, and how you can configure OSPF. You can configure any routing protocol or static routing over tunnel. But before starting the configuration, guys, let me make you understand what is DMVPN. So as you know, DMVPN stands for Dynamic Multi-Point Virtual Private Network. Dynamic Multi-Point Virtual Private Network. It is a network technology. DMVPN is a technology that allow to connect multiple sites together over public network. Like here in this topology, you can see we have multiple sites. This is my headquarter. This is my, let's say, branch 1. This is branch 2. Let me write over here. This is my headquarter, or we can say hub router. This is spoke 1 or branch 1, spoke 1, R2, and this is spoke 2, R3. Here let me write spoke 2. Right, we have multiple branch, and through DMVPN what we can do, DMVPN allow us to connect all sites together over public network. As you can see here, this is my public network. All sites like spoke 1, spoke 2 and main branch hub or headquarter, all are connected together through internet. Right, here we will configure the DMVPN and tunnel IP address is 192.168.10.0/24. So this network ID I will use for tunnel interfaces on the routers. Okay, so DMVPN is used to connect multiple sites together over public network. DMVPN provides a scalable and flexible solution for connecting multiple sites in a secure environment. Or you can say DMVPN use. See guys, DMVPN, we will have the multiple types of topology in DMVPN as well. Like if I will talk about DMVPN phase 1, let me discuss about phase 1. So in DMVPN phase 1, my topology will be hub and spoke. Hub to spoke means two branch offices or a spoke branch cannot communicate with each other. They will communicate through hub router. Like if this user from this network 20.1.1.1 want to communicate with 30.1.1.1, so it will communicate via hub router, because here my topology will be hub to spoke. Here we will have one tunnel, and the same tunnel is connected with R2 and then R3, like this. So see, there is no any tunnel between router 2 and router 3. So if router 2 want to communicate with router 2, or users which is connected with router 2 want to communicate with the user who is connected with router 3 in this branch, they will communicate via hub router. So here we will have lots of load on hub router, on headquarter router. Right, this is the problem of DMVPN phase 1 as well, that in phase 1 communication between branch to branch is not possible. Communication between branch to branch is possible via hub router only. Right, so this is the first problem of phase 1. In phase 2, our topology will be like full mesh. In phase 2, DMVPN topology will be full mesh topology. Phase 2, here topology will be full mesh. Full mesh topology means branch offices can communicate with other branch offices directly, but here we have problem that we cannot perform summarization on headquarter. Like we are configuring phase 2, we have configured phase 2 over here. On the tunnel we have configured EIGRP routing protocol, let's say, and router 3 is advertising 100 prefixes to R1. So if R1 on this router, if you will perform the summarization, right, again in phase 2, after performing summarization, spoke routers cannot communicate directly, right, because here next hop IP address will change, right. In case of DMVPN phase 2, we will understand while configuring DMVPN phase 1. Okay, and in phase 3 we will have full mesh topology and we can achieve summarization as well. In phase 3 also we will have full mesh topology and we can achieve summarization as well. Okay, so we will understand a step by step configuration, don't worry. If I will talk about the key feature of DMVPN, so key feature of DMVPN is it's dynamic in nature, right. It will be dynamic in nature. You will see when I will configure DMVPN, because DMVPN uses some protocols like NHRP protocol, right. NHRP protocol. What is the use of NHRP protocol in DMVPN, guys? So as I told you, that key feature of DMVPN is it is dynamic in nature. So it is using a protocol such as NHRP to dynamically stabilized connection between branches and to maintain the connection as well, right. We have a protocol called NHRP. NHRP stands for next hop resolution protocol. So what is the use of NHRP protocol? It's very simple. NHRP protocol is used to resolve, you can say, if interviewer is asking you, this type of question, that what is the use of NHRP protocol in DMVPN and what is NHRP protocol. So you can say NHRP protocol is used in DMVPN to resolve the next hop IP address for destination network dynamically. What I am saying, NHRP protocol used in DMVPN to resolve the next hop address for the destination network dynamically. Let's say in this topology 20.1.1.1 want to communicate with 30.1.1.1. So router 2 need what? Next hop IP address of 30.1.1.1. Next hop IP address for to forward traffic to 30.1.1.1. So NHRP protocol is responsible to resolve the next hop IP address dynamically. That's why we are saying DMVPN is dynamic in nature, right. After that, in DMVPN environment, where we can connect multiple sites in full mesh topology, and NHRP play a very big role to stabilizing and maintaining direct communication between the sites. When when a packet need to be forwarded to destination, let's say router 2 want to send some traffic to router 3, right, router 3 LAN network, in the router 3 LAN network. So when a packet need to be forwarded to a destination site, NHRP helps to resolve the next hop IP address. This is the main point about NHRP protocol. So always keep in mind, NHRP protocol is used to resolve next hop IP address in DMVPN. That's it. Okay. If interview is asking question, what is NHRP, then configuration we are going to understand here, right. And after that, we have some types of message in NHRP. Guys, there are two most important messages. One is registration message and second one is resolution message. NHRP registration message and NHRP resolution message. So when a site wants to communicate to other branch offices, what I am saying, when a site want to communicate with another site, it register its on public IP address and its on tunnel IP address to its local private IP address with the NHRP server. Let's say in this topology, as you can see here, we will run NHRP protocol and a router. In NHRP we have two types of router. One is NHS and one is NHC. Next hop server and next hop client. Guys, your hub router is your NHS. Hub router is NHS. Let me write here. We have two types of router in NHRP protocol. First one is NHS, and second one is NHC. NHS stands for next hop server, next hop server, and NHC stands for next hop client, next hop client, right? Your hub router is NHS. You will configure your hub router as NHS. Hub router is your NHS, and your spoke router will be configured as client, spoke, or you can say branch. So all spoke router or branch routers will register their self to hub router on server. So this is also a role of NHRP by sending registration message. What I am saying, that see, this hub, this is a spoke router. It have one public IP address and one tunnel IP address, protocol address 192.168. let's say 10.2. So router 2 will tell to NHS, this is NHS next hop server. It will tell that my protocol IP address is, my tunnel IP address is 192.168.10.2, and my NBMA address means my public IP address is 2.2.2.1. In the same way, router 3 will also register, and router 1 will maintain one table called NHRP table, because this router is what? NHS, and this router is NHC, and this router is also, router 3 is also NHC. Done. This is your server. Now server routers maintain one NHRP table. It will maintain one table. Which table? NHRP table. In the table, it will make entry when R1, sorry, when R2 will register their self to hub router. It will store entry like this: 192.168.10.2 is the IP address of tunnel destination, and what is the NBMA address of this IP address? 2.2.2.1. and there will be one more entry, 192.168.10.3, and NBMA address of this IP address is 3.3.3.1. so who have registered their IP address? All branch offices. All branch offices will register their public IP address and tunnel IP address to server, to NHS, right? So now question is, who will tell to router 2 that who is your NHS? So you will configure the IP address of NHS on branch router, on spoke router, on router 2 and on router 3. I will configure that your NHS is 192.168.10.1. See here, I will configure IP address on tunnel interface, that will be, let's say, tunnel 1, and IP address will be 192.168.10.1 over here on router 1. I will configure tunnel 1, and this will be my IP address. Here also I will configure one tunnel, and tunnel IP address will be 10.2. Here on R3 also we will configure one tunnel, and here IP address will be 10.3. Getting my point? Right? Router 1 is hub router and router 1 is NHS. We will configure that on spoke branch, on branch router or on spoke router. Now we have second type of registration messages. Hope now registration message is clear to you, that all branch offices will register their self by sending registration message to server, NHS to next hop server. Done. After that we have one more message, that is NHRP resolution message. So when a side want to communicate, first of all always keep in mind the registration message. When a side want to communicate with another side, it register its own public IP address and its local private IP address with the NHRP server. And resolution message, when a side want to send a packet to a specific destination site, it query the NHRP server to resolve the next hop for that destination. What I am saying means, when 20.1.1.1 want to communicate with 30.1.1.1, router 2 will will send resolution message to router 1, to server router, to ask what is the NBMA address, or what is, sorry, not NBMA address, what is the next hop IP address for 30.1.1.1. So if you will ping 30.1.1.1 from here, router 2 will send one resolution message to router 1 to ask what will be the next hop IP address for this network. Getting my point? Okay. After that, NHRP server looks up their table. It will definitely look up their table, and then its database, and it will provide the mapping between destination private IP address and destination public IP address. Okay, so here router 1 will have information in the NHRP table that what will be the, see, next hop IP address for 30.1.1.1 is what, 192.168.10.3. This one will be the next hop IP address, and this is the NBMA address. So router 3 maybe know what is the next hop IP address, but router 3 don't know what is the NBMA address of destination. So it will send the resolution message to router number 1, and then router 1 will forward the traffic. So NBMA address. Now guys, let me make you familiar with the configuration. Let's start configuration from router number 1. First of all, here I am going to configure the tunnel. So see, on router 1, how many command I need to run? Interface tunnel 1. After that, IP address on the tunnel. So command will be IP address, and then 192.168.10.1, subnet mask 255.255.255.0. Then we will configure what? Tunnel source. Tunnel source will be fast Ethernet 0/0, or you can configure the IP address of fast Ethernet 0/0. In phase 1, just keep in mind, in phase 1, we will configure hub router as, on hub router we will configure, this is hub router, hub. On hub router we will configure MGRE, multi-point GRE. As you know, GRE is what? Point to point tunnel. GRE is point to point tunnel. So here on hub router we will configure MGRE. On a spoke router we will configure point to point GRE, only GRE. And here also on this spoke router also we will configure what? Only GRE. Okay, so this is the things which you need to keep in mind, that in phase 1 we configure MGRE on hub router and point to point GRE on a spoke router. So whenever you will configure MGRE, multi-point GRE, then you cannot define the destination IP address, tunnel destination IP address. So here we cannot define tunnel destination IP address. Here we will run command tunnel mode, after that GRE multi-point. Then we will run command, we will enable NHRP protocol. For that you will run command IP NHRP network ID. Network ID is, let's say, 1. That's it. So these command I will run on router number 1 only, and on router number 2, this is command of router 1 R1. This is command of R1. Let me show you, let me tell you the command of R2. On R2, see, we will run how many command? Tunnel interface 1. After that, tunnel IP address is 192.168.10.2. Subnet mask will be same. Tunnel source will be the fast Ethernet 0/0 on router 2 also, or you can define the IP address of fast Ethernet 0/0. After that, tunnel mode GRE. Here we don't need to configure the tunnel mode. Here we will configure what? Tunnel destination. Tunnel destination is, here we will define tunnel destination. Guys, what is the tunnel destination IP address? 1.1.1.1. The IP address, public IP address of router 1, NBMA address, what we call it, NBMA address, to the public IP address of destination tunnel. After that, we will enable NHRP protocol, definitely IP NHRP network ID 1, and then IP NHRP RP, as I told you that we need to define NHS also here. NHS. So IP address of NHS is 192.168.10.1. This will be the command on router number 2. So router 2 will register their self on this IP address, right? Now router 2 need NBMA address of this IP address. So here we have already defined the tunnel destination 1.1.1. I need to run this command on router number 2, and on router number 3 I will run command 3 tunnel interface tunnel 1 IP address will be 10.1.192.168.10.3. subnet mask will be same, and tunnel source will be fast ethernet 0/0. tunnel destination will be this one, IP NHRP network ID 1, and IP NHRP NHS IP address is this. It will be same, right? So these command I need to run on the router for phase 1. This is for phase 1. So let me do, guys, let me take access of router 1 here. This is router 1. Here I am going to configure phase 1 first. And if you want to see the IP configuration, so IP interface brief exclude unassign. I have configured only IP address till now on the router. See, on fast ethernet 0/0 I am running IP 1.1.1.1, and on ISP side I am running 1.1.1.2, and this router can ping 1.1.1.2 IP address. You can see, right? It is able to ping internet public IP address, right? Now one thing you already know, that whenever we configure VPN or NAT, so on each router we need to configure one default route, yes or no? So on each router we need to configure one default route towards ISP, towards internet. So here I am going to configure one default route first. IP route 0.0.0, 0.0.0, exit interface will be fast ethernet 0/0, and next hop IP address is this one. Done. Now let me take you to router number 2, guys. On router number 2 also, if you want to verify the IP configuration, you can check. So IP interface brief exclude unassign. By the way, I have already mentioned IP address in the topology, so you can see the IP there also. And ping 2.2.2.2. I am able to ping ISP or not? Yes, I am able to ping ISP as well, right? Here also I am going to define one default route, IP route 0.0.0, 0.0.0, and exit interface fast ethernet 0/0, and next hop IP address is 2.2.2. Now from router 1 to router 2, public IP address should be reachable with each other. So let me check that public IP address are reachable or not. Do ping 1.1.1.1 from here. You can see public IP address, public to public reachability is there, yes or no? So done. This is fine. Now let me show you the IP configuration of R3, guys. So IP interface brief exclude unassign. Here also you can see the IP address on fast ethernet 0/0. I am running 3.3.3.1. Let me ping 3.3.3.2, 3.3.3.2, which is running on ISP on internet side. Okay, done. It's working fine. Let me configure one default route, IP route 0.0.0, 0.0.0, and next hop IP exit interface is F0/0, and next hop IP is 3.3.3.2. Done. Now let me configure the tunnel on router number 1 first. And if you want to verify the connectivity between public IP address, so you can ping 2.2.2.1. See, I am able to ping 2.2.2.1, ping 3.3.3.1. I am able to ping 3.3.3.1 also. Now I am going to create one tunnel over here, interface tunnel 1, and IP address on tunnel 1 interface is 192.168.10.1, subnet mask 255.255.255.0. Then tunnel source is fast ethernet 0/0, or you can configure tunnel source as 1.1.1, IP address of fast ethernet 0/0. Then tunnel mode GRE multi-point. After that IP NHRP network ID 1. That's it. We need to run only these command on router number 1. Now your tunnel interface is up, you can see. Now let me configure router 2. So let me take you to router 2, guys. And now on router number 1, you can see the NHRP table. Now NHRP table is empty. So IP NHRP. This is a command to check NHRP, or you can run command so DMVPN. So here also you can see we don't have any tunnel, right? NHRP table is also empty. So when we will configure what NHS IP address on branch offices, then it will register yourself to server router. So let me take you to router number 1. Here I am going to create the tunnel first. Interface tunnel 1, IP address 192.168.10.2, 255.255.255.0. Then tunnel source is fast ethernet 0/0. Then tunnel destination is 1.1.1.1. After that, IP NHRP network ID is 1, and then IP NHRP NHS. After that, IP address of NHS server 192.168.10.1. That's it. Now on router number 1, if you will check NHRP table, so IP NHRP table, you can see there is one entry. The destination tunnel IP address is this one 192.168.10.2, and NBMA address means public IP address of this tunnel IP address is 2.2.2.1. And type, here you can see type is dynamic, means it have learn this NBMA address dynamically, right? In the same way, router 3 will also register yourself when I will configure router 3. So let me configure router 3 also. Interface tunnel 1, IP address 192.IP address 192.168.10.3, 255.255.255.0. Then tunnel source is fast ethernet 0/0. Then tunnel destination, that is 1.1.1. Then IP NHRP network ID 1. This is network ID is locally significant. You can configure same also and different also. This is similar like process ID of OSPF, right? We can run multiple NHRP protocol on a single router. So to identify the NHRP process, we have NHRP network ID. Okay. Then IP NHRP NHS. NHS IP address is 192.168.10.1. Done. So I have configured everything over here also. Now the router 3 have also registered yourself on router number 1. Here you can check. So NHRP, you can see there is 2 entry. This one and this one. Or you can run command what? So DMVPN. So DMVPN. So here also you can see the router 1 have 2 tunnel. This is the NBMA address of 192.168.10.2, and this is the NBMA address of 192.168.10.3. So whenever router 1 need to forward traffic to 192.168.10.3, right? Whenever, what I am saying, router 1 need to forward traffic to 192.168. Let's say I am pinging from router number 1, ping 192.168.10.1. So here source IP address 10.3, sorry, 10.3. So source IP will be 192.168.10.1, destination IP 192.168.10.3. After that, it will add one GRE header, header, and then it will add one new IP header. In new IP header, source will be what? Source will be 1.1.1.1, my public IP address of tunnel interface, and destination will be this one, 3.3.3.1, because it have the NBMA address of this IP address in table. Because of that, it is able to encapsulate the packet. Otherwise, router cannot encapsulate the packet. Let's say router don't have the NBMA address of this IP address, so router cannot forward traffic to this IP address. Okay, so this is the concept here. Done. Now let me show you. Let me capture this link also, and I am going to see. I have captured the link. And if you want to see the NHRP registration message, what I am going to do, I am going to shut down the tunnel interface, this tunnel interface, shut down, and again I will run no shut command. on router number 2. So again, when this tunnel will come up, it will send one NHRP registration message. Are you able to see the NHRP registration message? Source is 2.2.2.1 and destination is 1.1.1.1. So it is forwarding NHRP registration message to NHS, right? So we have configured the tunnel destination IP address here, right? Because on router number 2, if you will check NHRP table, so IP NHRP, we don't have any entry. But because here we have configured what? Point to point tunnel. We have defined what? Tunnel destination IP address. So run interface tunnel 1. These are the troubleshooting command, guys. You can write down somewhere. So here we have defined the tunnel destination IP address 1.1.1. So that's why router 1 is encapsulate the traffic. Okay. So router 2 have sent the NHRP registration message. Now what I am going to do, I have capturing here. I am going to ping from router 1 to, let's say, router 2. From router number 1, ping the tunnel IP address of router 2, 192.168.10.2. Okay, and see the ICMP request. Now let me stop the capturing here and see the ICMP. In the outer header, source is 1.1.1 and destination is 2.2.2.1. How it have find the NVMe address of 192.168.10.2 in NHRP table? Okay, because you have ping which IP address? 192.168.10.2. This is your ICMP traffic. After that, IP header, actual IP header. In actual IP header, source IP is the IP address of exit interface, the tunnel interface, and destination is 192.168.10.2. After that, GRE header, and then the outer IP header. Source is 1.1.1.1, destination is 2.2.2.1. So it have information, yes or no? Now, very important thing is router 2. Can router 2 have the NVMe address of 192.168.10.1, right? Means router 2 can ping 192.168.10.2. Can router 2 ping router 3 channel IP address 192.168.10.3? Yes, it is able to ping and trace route 192.168.10.3. So see, traffic is going via router number 1. And when I am pinging this IP address, so router 2 don't have NVMe address of this IP address. So here if you will capture the link, let me capture now this link. See what will happen when router 2 will forward traffic to router number 3. Start Wireshark. Router number 2. Again I am going to send ping traffic. See in the ping, where is ICMP traffic? I think I have filter. Any traffic? No. Here we have. Okay, I have trace route. Let me ping. Okay, I have ping, and now you can see. Let me stop the capturing. Router 1 have encapsulate one packet where source IP is 192.168.10.2, destination is 192.168.10.3. But here you can see in the outer IP header, source IP address is 2.2.2.1, but destination is not 3.3.3.1. It's 1.1.1.1 tunnel destination IP address. Getting my point? So in public IP address, it will forward traffic to router 1 and router 1 will forward traffic to router 3. Getting my point? What I am saying, when I am pinging router 3 from router number 2, so router 2 is forwarding traffic to router 1 and then router 1 is forwarding to router 3. And when router 3 will generate reply, source will be 192.168.10.3 and destination will be 192.168.10.2. Again, router 2 don't have the NVMe address of 192.168.10.2. So it will forward reply to router number 1 and router 1 will forward to router 2. Like this, DMVPN phase 1 works. Now we have reachability between tunnel interface. Now the LAN user. how LAN user will communicate with each other. So here on the tunnel interface, what we can do, we can configure any routing protocol, or we can configure the static routing. First of all, I am going to show you the static routing configuration. Guys, on daughter number 1, we need to configure 20 network and 30 network. So say IP route 20.1.1.0, subnet mask 255.255.255.0, and exit interface is tunnel 1, and next hop IP address is 192.168.10.2. Because this router have the NBMA address of this IP address, yes or no? So it can encapsulate the packet. Now IP route 30.1.1.0, subnet mask 255.255.255.0, exit interface tunnel 1, and next hop IP address 192.168.10.3. Done. Let me configure a static routing on router number 2. Config T, IP route 10.1.1.0, 255.255.255.0, tunnel 1 is the exit interface, and next hop IP address 192.168.10.1, and IP route 30.1.1.0, 255.255.255.0, tunnel 1, and next hop IP address 192.168.10.3. Done. Let me configure a static routing on R3 also. Exit IP route 10.1.1.0, 255.255.255.0, tunnel 1, and 192.168.10.1. IP route 20.1.1.0, 255.255.255.0, exit interface tunnel 1, and next hop IP address 192.168.10.3. Done, guys. I have configured the static routing. What happened? Invalid next hop IP address 192.168.10.3. Tunnel 1, this is IP route 30 network. So 20 network, I am configuring 20 network over here. Next hop IP address is 192.168.10.3. It's fine. On router number 2 also I have configured this entry. So here it's working 10.3. Here next hop IP address will be 10. Not 3, 10.2. Sorry, 10.2. Done. Now if you will check the routing table, so IP route static, you can see there is 2 entry, 20 network is there and 10 network is there. Now if you want to ping 10.1.1.1 and source 30.1.1.1 from router number 3, see, I am able to ping the LAN user which is connected on hub router, and I am able to ping 20.1.1.1 also when source is 30.1.1.1, right? But see, I am able to ping all branch offices are able to communicate with each other, all LAN users are able to communicate with other sites LAN user. Getting my point? Now from router number 2, I'm going to trace route, guys. Trace route 30.1.1.1 and source is 20.1.1.1. So my traffic is going via router number 1. So this is problem in phase 1. In phase 1, all branch offices will communicate with each other through hub router. Now I am going to show you the dynamic routing protocol right over the tunnel interface in phase 1. So let me remove the static routing configuration. You can configure the static routing like this, okay? But if you don't want to configure the static routing, so you can remove it. Do so, run pipe section IP route. Here I am going to remove the static routing entry. This entry first. Say no, and say no to this entry also. So I have removed both entry from router number 2. Let me remove entry from router 1 also. Do, here we have entry in front of me. So let me say no over here. No 30 network and no 20 network also. No. Done. I have removed the static routing configuration. Let me remove a static routing configuration from router 3 also. Do so, run section IP route. Say no. This no this. I have removed the static routing configuration. Now again, if you will do ping 20.1.1.1 and source is 30.1.1.1. See, it's not working. Now ping will not work because this router don't have root for this network. It have one default route in the routing table, but it don't have the NBMA address, right? So if next hop for this network should be what? 192.168.10.3, right? And it will forward traffic to router number 1. Now let's understand the dynamic routing configuration of our tunnel. Guys, in dynamic routing, first of all, I am going to configure RIP routing protocol. So let me take you to router number 1. Here I am going to say router RIP version 2, no auto, summary and network 10.1.1.0 and network 192.168.10.0. So I have advertised both network, tunnel and LAN in RIP protocol. Let me configure RIP on router 2 also. Router RIP version 2, no auto, summary and network 20.1.1.0 and network 192.168.10.0, right? So IP route RIP, it have learned 10 prefix 10.1.1.0, right? In the same way router 3 will also learn. Let me configure RIP on router number 3. Router RIP version 2, no auto, summary and network. Network is 192.168.10.0 and network 30.1.1.0. So IP route RIP. See, it have learned 10 prefix, but it have not learned 20 prefix. And router 1 will learn both 20 and 30. So IP route RIP. See, 20 network is there and 30 network is there. But my branch offices have not learned. So like router 2 have not learned 30 prefix. So IP route RIP 30 prefix. So reason is, as you know, in dynamic routing we have in distance vector routing protocol we have one feature called a split horizon. A split horizon feature is what? If router 1 is receiving 20 network on tunnel 1 interface, so it will not forward same network from the tunnel 1 interface, from the same interface, from the receiving interface, right? So here a split horizon by default is enabled. So I need to disable a split horizon. Then router 1 will advertise 20 network to router 3 and 30 network to router 2, right? 30 network to router 2. So let me do that also on router number 1. Here what I am going to do, I'm going to say config t interface tunnel 1 and no IP split horizon. After running this command, you can check the routing table of router 2. It have not learned. Wait for some time, it will learn 30 network also. After 30 seconds, it will send the update message. Let me check on R3. R3 is learning 30 network, 20 network or not. No, it is not receiving. Let me do one thing. I am going to down the tunnel interface ons. Interface tunnel 1 shutdown and then no shutdown. Config t interface tunnel 1 shutdown. Wait for some time and say no shutdown. And now let me check the routing table. So IP route RIP. So you can see this router have learned 10 also and 30 also. But next hop IP address is 192.168.10.3. 10.3. But router 2 don't have NBMA address of 10.3. So it will forward traffic to router 1 only. Ping 30.1.1.1 and source is 20.1.1.1. See, it is able to ping. Ping will work. I think router 3 have not received 20 network. Yes, it have not received 20 network. So here also I am going to down the tunnel interface. This is problem of software only, right? In real time you will not get this type of problem. Say no set again, no set, and so IP route rip. So it have learned 20 and 10 now. Now we can ping. See, ping is working, and trace route. Trace route 30.1.1.1, source is 20.1.1.1 numeric. Traffic is going via router number 1, right? So this is problem of phase 1, guys. If you are configuring any routing protocol, let me configure EIGRP also. See, this is the configuration of RIP. Now I am going to configure EIGRP. So let me remove the configuration of RIP first. Say no router RIP. No router RIP on router number 1. No router RIP on router number 2 also. No router RIP. And let me disable RIP on router number 3 also. Config T and no router RIP. Done. I have removed the RIP configuration. Now you can see again the routing table. Do so IP route. Only directly connected networks are there, right? 1, 92 and 10. This is on tunnel interface. This is on physical interface, and this is LAN network. This is LAN network, and we have one static route. Now let me configure EIGRP router. EIGRP. After that, can I configure name mode over here? No. Router EIGRP S number 10, and then network 192.168.10.0 wildcard mask 0.0.255 network 10.1.1.0 and 0.0.255. Guys, it will send the update message on multicast address. As you know, RIP is also sending the update message on multicast address, but in RIP we don't have any neighborship. Directly RIPs here routing table with the neighbor, but in EIGRP first routers will become what? Neighbor. So here we need to run one more command. We need to actually map the public IP address. So interface tunnel 1, and here we need to run this command only. IP NHRP map multicast address. I am telling this router to map multicast address into the address into the NBMA address which is available in NHRP table. Dynamic we can say, or directly we can say what? 1.2.2.2.1, and we can say here 3.3.3.1. So it will map multicast packet into this IP address and this IP address. Done. Now let me take you to router number 2. Router EIGRP AS number 10 network 20.1.1.0 wildcard mask 0.0.255 network 192.168.10.0 wildcard mask is 0.0.255. Done. After that you can see the neighborship adjacency. Do so IP EIGRP neighbor. Neighborship is there. Yes or no? Neighbor is 192.168.10.1. Let me configure EIGRP on router 3 also. On router number 3 router EIGRP S number 10 network 192.168.10.0 wildcard mask is 0.0.255 and network 30.1.1.0 0.0.255. Here also we have EIGRP neighborship. So IP EIGRP neighbor. Done. And routing table. So IP route EIGRP. So it have learned 10 and 30 is the directly connected. So again it is not learning 20 network. Why? Because of split horizon. Again we need to disable split horizon on router number 1. Interface tunnel 1 and say no IP split horizon for EIGRP AS number 10. After running this command, you can verify the routing table of router 3 or router 2. So here you can see 20 network is there, right? And EAGRP neighborship is going down, so IP EAGRP neighbor. Now you can see the neighbor is up, but it is going down as well. Here you can see the log message, graceful restart. So here also on branch offices also I need to run the multicast mapping command. Interface tunnel 1 IP NHRP map multicasting to 1.1.1. That's it. Now we don't have any problem. So this is the configuration of EAGRP on tunnel interface in phase 1. Interface tunnel 1 IP NHRP map multicast into 1.1.1.1. That's it. Right. Again you can see so IP route EAGRP. This router have 20 network and 10 network, 30 network. So 20 is directly connected and it have learned 10 and 30. Now again I can ping 30.1.1.1 and source is 20.1.1.1. You can see we have reachability and trace route 30.1.1.1, source is 20.1.1.1 numeric. You can see traffic is going via router number 1. Now guys, I am going to show you the OSPF configuration over here. Let me remove the EAGRP configuration. No router EAGRP 10. On router number 2 also say no router EAGRP 10. No router EAGRP S number 10. And on R3 also let me run no router EAGRP S number 10. I have removed the EAGRP configuration from all routers. Now let me configure OSPF. Router OSPF process ID 1 and network 192.168.10.0, wildcard mask 0.0.255, area is let's say 0. Network 10.1.1.0, wildcard mask 0.0.255 and area is 0. I've configured the OSPF on router number 1. Let me configure OSPF on router 2. Router OSPF process ID 1, network 192.168.10.0, 255, area 0, and network 20.1.1.0, 0.0.0.255 and area is 0. Done. I have configured OSPF on router number 2 also. Let me configure OSPF on router 3. Router OSPF 1 and network 192.168.10.0, 0.0.255, area is 0 and network 30.1.1.0, 0.0.255, area 0. Done. I have configured OSPF, but we have one problem in OSPF. On tunnel interface, OSPF network type is guys point to point. But here in DMVPN phase 1 or in DMVPN, if you are configuring OSPF, always configure the network type broadcast. You can configure broadcast. You can configure point to multi-point network type. So as you know, we have multiple types of network type in OSPF. So by default, so IP OSPF interface tunnel 1. You can see here network type is point to point. But if here network type is point to point, so neighborship will not come up. Yes or no? See, neighborship is resetting again and again. So here on router number 1, I am going to run one command. Command is exit interface tunnel 1 and IP OSPF network type is broadcast. That's it. On router number 2 also say interface tunnel 1 IP OSPF network broadcast. And on router number 3 also let me run this command. Interface tunnel 1 IP OSPF network broadcast. That's it. Now if you will check the routing table of router 3, so IP route OSPF, it have no any prefix, so IP OSPF neighbor. So neighbor is in two-way state. Soon it will come in full state. Then it will exchange the database. After that, router will build a routing table. Okay, just wait for some time. So IP OSPF neighbor. this neighbor is in two-way state and this is in X start state. Wait for some time, it will take some time. These are the problem of software only. So this is phase 1 configuration. Hope now phase 1 configuration is clear, and now you can see neighborship is full. And so IP route OSPF, it have learned 20 prefix, soon it will learn 30 prefix as well. You can see 30 prefix. And on branch offices, here on router number 2, so IP P route OSPF. Router 2 have also learned 10 network and 30 network. Now can I ping 30.1.1.1 if source is 20.1.1.1? Yes, I am able to ping. Trace route 30.1.1.1 and source is 20.1.1.1 numeric. You can see traffic is going via router number 1. Okay, so IP route OSPF. In the routing table, next hop is 420 network, 430 network. Next hop is 192.168.10.1. Right? Okay, guys. If you will, configure, if next hop is not this one, let's say next hop is 192.168.10.3, then also router 2 will forward traffic to router 1 only, because this router don't have the NBMA address of 192.168.10.2. Done. This is the phase 1 configuration. Now let's discuss about the phase 2 configuration. In phase 2, guys, we will configure MGRE on everywhere. Here also we will configure what? MGRE. And here also we will configure MGRE. On branch office also, and on your headquarter also. In phase 2, our concern is there should be reachability between branch to branch directly. Means this user from this network can communicate with user in this network directly, like this, through internet, not via a spoke router. But if we are running any routing protocol like OSPF, so OSPF neighborship will be there like this only, but traffic forwarding will be like this. Okay, so let me show you the configuration of phase 2. It is very easy. If you have understand the configuration of phase 1, you can understand the configuration of phase 2 also. To configure phase 2, we don't need to change anything on router number 1. Router 1 configuration will be same. So run interface tunnel 1. So this is the configuration of phase 1, and here I am not going to change anything, right? Here I am not going to change anything. Let's say if you will configure distance vector routing protocol, so you have this command, no IPA split horizon. After that, mapping and rest thing is perfect. Done. But on here, network type is also broadcast. So if you will configure OSPF, so you don't need to change network type. Okay. On router number 2, so run interface tunnel 1. Here we need to change the configuration. First of all, we need to remove tunnel destination IP address, and tunnel mode will be multi-point GRE. So directly I am going to remove no interface tunnel 1. I am going to run this command. After that, interface tunnel 1 IP address 192.168.10.1 255.255.255.0. Then guys, tunnel source F0/0 tunnel mode GRE multi-point. Here also I have configured what? Multi-point GRE. And now when you configure multi-point GRE, you cannot define the destination. I'm going to configure NHRP protocol. IP NHRP network ID is 1, IP NHRP NHS 192.168.10.1, and you need to run one more command over here for mapping, IP NHRP map, because here we need to make the static entry for the destination tunnel IP address and NBMA address of destination. So tunnel IP address is 192.168. Remote tunnel IP address 10.1, and the NBMA address is 1.1.1.1. So it will maintain one NHRP table, do so IP NHRP, you can see. And here type is static, it will never expire. Getting my point? So here in DMVPN phase 2, manually on branch offices, we will map the destination tunnel IP address and destination NBMA address. This is the difference in phase 1 and in phase 2. Apart from this, rest commands are same. Okay, now let me take you to router number 3, and here also I am going to say no interface tunnel 1, and interface tunnel 1 IP address is 192.168.10.3 255.255.255.0. After that, tunnel source is fast Ethernet 0/0, then tunnel mode GRE multi-point, and IP NHRP network ID 1 IP NHRP NHS 192.168.10.1 and one mapping IP NHRP map 192.168.10.1 and public IP address is this one. Done. It have also maintained one NHRP table. So IP NHRP table. So in phase 2 we configure MGRE on branch office also and on hub router also. Right. This is the difference in phase 2 from phase 1. Now what I can do, let me check the connectivity between tunnels. From router number 1, I'm going to ping 192.168.10.2. So it is not able to ping 10.2. Let me ping 10.3. And so IP NHRP. So it have the NBMA address of 10.2 also and 10.3 also. So it should work, ping should work. Ping 10.1.1.3. 10.3 is pinging, 10.2 is not working. So let me check configuration on router 2, guys. Here I think I have configured something wrong. So run interface tunnel 1. Here I have defined the tunnel IP address. After that, mapping network ID, okay. NHS IP address is also fine. Tunnel source is fast Ethernet 0/0 is fine, and tunnel mode is this one. So here configuration is okay. Ping 192.168.10.1, and here let me check the NHRP table. So IP NHRP 192.168.10.1 and NBMA address is this one. Let me ping 1.1.1 from here. Public reachability is there or not? So yes, public reachability is there, but it is not able to ping the tunnel IP address. So I need to now troubleshoot it. That why here we don't have connectivity. It have registered yourself to router 1. Yes. So IP NHRP 192.168.10.2 NBMA address is 2.2.2.1. It's perfect. Let me send ping traffic again. It's not working. Let me capture the link over here. So which router is sending hello message? So IP protocol. So IP protocol. Here I am running a protocol OSPF1. First of all, let me say no router OSPF1. No router OSPF1. And now so IP protocol. Only NHRP protocol is running there. Here so IP protocol. Here also OSPF is running. So let me say no router OSPF 1, and on R3 also let me remove the OSPF configuration. No router OSPF 1, and from router number 1 I am going to ping 192.168.10.2. Let me check, it is forwarding ICMP request. Yes, it is forwarding ICMP request, but it is not getting the reply. 2.2.2 192.168. everything is okay. So router 2 is not forwarding the reply, router 2 is not giving the reply. Here we don't have any problem. Router 1 is sending ICMP request message. So let me capture this link. See, it is sending the ICMP request. Let me do one thing. From router number 3 I am going to ping 192.168.10.1. Now router 3 is able to ping this IP address. So router 1 can also ping. This was the problem of software only. Okay, I need to ping. Oh, I have pinged it from router number 3. No. I need to ping from router 2, 192.168.10.2, 10.1. And let me check the capturing. This router is also sending ICMP traffic to destination 1.1.1. So everything is okay. Tunnel source here is 192.168.10.1. No. I think I have configured wrong IP address, tunnel source IP address. So run interface tunnel 1. Here you can see the tunnel source IP address is IP NHRP NHS. Tunnel source IP address is fast ethernet 0/0. So this one is everything, configuration is fine. Here I have configured IP address what 10.1. This is wrong, right? Here IP address would be 10.2. So let me correct it. Interface tunnel 1 and IP address 192.168.10.2, 255.255.255.0. No, sorry, this was the wrong configuration. Okay, now let me close. Okay, I will use the capturing later. So now you can see router 1 is able to ping this IP address. Yes, 192.168.10.2 also and 10.3 also. Done. Now again we can run what routing protocol or a static routing. So here I am not going to configure a static routing. Let me configure directly routing protocol. Let me configure EIGRP. So on router number 1 I am going to configure EIGRP. Router EIGRP S number 10, network 192.168.10.0, 0.0.255, and one more network is 10.1.1.0, 0.0.255. Done. I've configured EIGRP on router 1. Let me configure EIGRP on router 2. Router EIGRP is number 10, network 192.168.10.0, 0.0.255, and network 20.1.1.0, 0.0.255. Done. Let me do one thing. As you know, on interface tunnel 1 we need to run command IP NHRP map multicast to 1.1.1.1. this command. That's it. So IP route EIGRP, it have learned 10 prefix, you can see here. Done. Now let me configure EIGRP on router number 3. Config T, router EIGRP is number 10, network 192.168.10.0, 0.0.255, and network 30.1.1.0. 0.0.255. That's it. So I have configured EIGRP on all routers. Here I am going to verify the routing table. So IP route EIGRP, it have received 30 prefixes. We need to disable split horizon, and we need to run one more command here, that is IP NHRP map multicast to 1.1.1.1. That's it. Now let me disable the split horizon on router number 1. Interface tunnel 1, no IP split horizon for EIGRP is number 10. Now these routers will receive prefixes, branch offices. Let me check here. So IP route EIGRP, it have learned 30 network and 10 network. Done. And next hop IP address is 10.1. So router 1 is modifying the next hop IP address. Here I am going to tell to router 1, please do not modify the next hop IP address. So that actually, see, now router 2 is receiving 30 prefix, but next hop IP address is 192.168.10.1. So router 2 will forward traffic to router number 1 only, right? You can check ping 30.1.1.1 and source is 20.1.1.1. I am able to ping and trace route 30.1.1. Oh my god. And source is 20.1.1.1. See, traffic is going via router number 1 like phase 1. But here I will run one command on router number 1. I will run command no IP next hop self for EIGRP as number 10. Now guys, see here. So IP route. So we have IP route EIGRP. I have 30 network, and this time next hop IP address is 192.168.10.3. But router 2 need what? The NBMA address of 192.168.10.3. Right? NBMA address. And so IP NHRP. In NHRP table, there is only one entry. The NBMA address of 192.168.10.1 is 1.1.1. That router 2 don't have NBMA address of 192.168.10.3. So it will send one message. See, when I am going to trace route 30.1.1.1 and source is 20.1.1.1. First packet will go via router number 1. But if I will trace route now, you can see now router is directly forwarding traffic to router 3, right? Directly forwarding traffic to router 3, and so IP NHRP. And in NHRP table also you can see there is 2 entry. The NBMA address of 192.168.10.3 is 3.3.3.1. So in phase 2, what is happening? See here in the capturing. When I have sent the first trace route traffic, this is the first trace route traffic. Before that, router have sent one NHRP resolution message, and then router 1 have sent NHRP reply message. Guys, in resolution message, router 2 will ask what is the NBMA address of 192.168.10.2. What is the NBMA address of 192.168.10.3, and then through reply message, resolution reply message, router 1 will share this NBMA address, and then router 2 will store that in their NHRP table, and this entry is dynamic. Here you can see type is dynamic, this entry is static. Okay, so if I will clear NHRP table, clear IP NHRP. So now IP NHRP don't have NBMA address, router 2 don't have NBMA address of 192.168.10.3. So it will send what? It will send NHRP resolution request. Let me show you again. Let me ping 30.1.1.1 and source is 20.1.1.1. See, it have sent one resolution message. Yes, here you can see the resolution message and resolution reply message. And now again it have the NBMA address of 10.3. So IP NHRP. So in DMVPN phase 2, first time branch offices will send traffic to hub router. After that it can communicate directly. Okay guys, and now we have last. Okay, let me make you familiar with the problem of phase 2 first, then we will discuss phase 3. Now let's say router 3 have some more prefix here, 30.1.2.0/24 also, and 30.1.3.0/3024. Now router 3 is advertising these three prefix. Okay, let me create the loopback on router number 3. Interface loopback to IP address is 30.1.1. 30.1.2.1, 255.255.255.0. Exit interface loopback 3. IP address is 30.1.3.3.1, 255.255.255.0. I've created this loopback. Let me advertise it in EIGRP. So router EIGRP S number 10, network 30.1.2.0, 0.0.255, and network 30.1.3.0. It is advertising 3 network. Now what I want, on the hub router I want to summarize these prefix, and then I want to advertise to router 2. So let me do this on router number 1. What I want, see here EIGRP neighborship is resetting, so here we need to run command IP NHRP map multicasting. After that dynamic, we can say directly here dynamic. Done. Now what I need to do, I want to perform summarization here. So IP summary address for EIGRP 10 is, what will be the summary address of these three network? Summary address of these three network will be, guys, 30.1.0.0, subnet mask 255.255.252.0. You can summarize these three prefix. This is the summary address. Okay, so I have advertised the summary address, and now see on router number 2. So IP route, there is only one summary network is there. Just wait. 30.0.0.0 via, let me do one thing. I am going to down the tunnel interface once, say shut down, and again I am going to say no set. No set. Done. And so IP route EIGRP. EIGRP. Now you can see there is only a summary network, and next hop IP address is 192.168.10.3. 10.3. No, here on router number 1 I think I have run this command on wrong interface. Actually I need to run this command on tunnel interface, and see EIGRP neighborship is also breaking. So on tunnel interface tunnel 1 IP NHRP map multicast and 2.2.2.1 and 3.3.3.1. 1. Done. And then IP summary address for EIGRP 10 is 30.1.0.0, subnet mask 255.255.252.0, right? And I have, I think, remove this command. Yeah, done. Now let me show you here on router number 2. So IP route EIGRP 30 network is there, but next hop IP address is this one. Router 3 is not advertising this network. How it is storing 30.1.1.0 should be, let me do one thing. Here on router number 1 I am going to check the routing table. So IP route EIGRP 30.1.1.0. Okay, so router 3 is advertising summary prefix. Let me check here. I think here I have run command like 3.0. Oh, let me say no over here, and network. Okay, I have advertised all individual prefix over here, 2.0 and 3.0. So router 2 should receive all individual prefix as well. let me do one thing, interface tunnel 1, and I am going to say again no to this entry, because let me check now. So IP EIGRP, so IP root EIGRP, it is receiving individual prefix. No, it is not receiving individual prefix. So actually, by default auto summarization is enable. So let me do one thing here. I am going to say router EIGRP is number 10 and no auto summary. Done. This is the problem. Router number 2 also I am going to, on router number 1 also let me disable auto summarization. Router EIGRP is number 10 and say no auto summary. And router number 3 also I am going to say no auto summary. Now let me check router 3. Router 1 have received all individual prefix or not. So IP route EIGRP. Now you can see router have received individual prefix. It will receive some more prefix here. 3.0. So let me check on router number 3. I think I have not advertised 30.1.3.0 0.0.255. Done. Now router 1 should receive these all prefix. Done. And what I want, see, router 2 have also received all individual prefix from router number 1. So IP route EIGRP, and next hop for all network is 10.3. So it's perfect. But when I will perform summarization on hub router, here in phase 2 problem is this only. We cannot perform summarization. Interface tunnel 1 IP summary address for EIGRP 10 is 30.1.0.0 255.255.252.0. I have advertised the summary route. Now you can see router 2 have one route only. So IP route EIGRP, and next hop IP address is what, 10.1.1.1, because router 1 is advertising this network. So if you will trace route 30.1.1.1 and source is 20.1.1.1, it is forwarding traffic via router number 1. First packet also, second packet also. So it will always communicate via router number 1 because I have summarized the network on router number 1. This is not with EIGRP only, with any routing protocol. In phase 2 you cannot achieve summarization. Okay, but let me discuss about the phase 3. Here I am going to say no to this command. No, I have removed it, the summarization. And in guys phase 3 we have only little bit different. Here on hub router we will configure one command, IP NHRP redirect. ICMP redirect. If you know ICMP redirect, you can easily understand DMVPN phase 3. And on branch office we will configure IP NHRP shortcut here also and here also. On both branch offices we will configure IP NHRP shortcut. On hub router we will configure IP NHRP redirect. Now see, in phase 3, if here I will summarize 30 network 30.1.0.0, so router 1 will advertise it through their next hop IP address 192.168.10.1. But when router 1 will forward traffic to 30.1.1.1, let's say from 20.1.1.1, it will forward traffic to router 1, and router 1 will send one redirect message that you are using suboptimal path. You can directly communicate with 30.1.1.1. You don't need to forward traffic to me. This is DMVPN phase 3. Let me show you by configuration. Here what I am going to do, I am going to add one command, interface tunnel 1 IP NHRP redirect. And on branch offices we will configure config t interface tunnel 1 IP NHRP shortcut. And on branch 2 also let me run interface tunnel 1 IP NHRP shortcut. That's it. Now you can see router 2 is receiving all 30 prefix, so IP route EIGRP 30 prefixes individually, and next hop IP address is the IP address of router 3. It's working fine, but when I am performing summarization on router 2, it is forwarding traffic via router number 1. So here what I am going to do, I am going to configure DMVPN phase 3. On router 1 I have run this command, and on branch offices I have configured the shortcut command. Okay, again I am going to perform summarization over here. IP summary address for EIGRP is number 10 30.1.1.0 subnet subnet mask 255.255.252.0. Summary address will be not this one, here it will be 0 30.1.0.0 and subnet mask 255.255.250.0. So I have advertised the summary address. Now see the routing table of router 2. Router 2, so IP route EIGRP. It have received one summary route. Next hop IP address is what? 192.168.10.1. So it will forward first packet to definitely headquarter to router 1 30.1.1.1. Source is 20.1.1.1. Done. It have sent the first packet to router 1, but see the second packet. It is forwarding second packet directly to router number 3 because it have so IP NHRP NHS. Sorry, NHRP table. You can see router 2 have the NBMA address of 192.168.10.3. So whenever you want to forward traffic to 30.1.1.0/24, this network is reachable via 192.168.10.3. Router 1 have tell to router 2 that you can, for 30 network, next hop will be this one and NBMA address is this one. Again router 2 will send what? First of all router 1 will send, see the capturing over here. When I have trace route, yes, router 2 have sent one NHRP resolution message for the NBMA address, and router 1 will send the redirect message. Okay, redirect message. After that router 2 will send resolution message for the NBMA address of tunnel destination 192.168.10.3, and then it will send the resolution reply. This is how DMVPN phase 3 works. Okay guys, so in this video we had discussed DMVPN phase 1, phase 2, phase 3. Like phase 1 you can configure OSPF, RIP or static routing in phase 3 as well. In phase 3 we have branch to branch communication and we can achieve summarization on hub router. So here routing protocol is compatible with DMVPN, but in DMVPN phase 2 routing protocols are not compatible because we cannot perform summarization on headquarter. Okay guys, so that's all for today. If you have learned something from this video, please hit on like button. If you have not subscribed my channel, please subscribe this channel. We will meet soon in next video. Till then, stay safe. Bye bye.